So, as usual, let's wait for first 5 minutes for those people to join. If they are joining, they can join, right? So let's wait for that. Until then, just do a sound check. Am I clear? Is my audio clear? Can you please confirm whoever is there in the live? Okay, as usual. Hi, Lakshmi. So, if you have any doubts, just put it in the chat. Okay, we are having some 3 minutes more, so I'll be able to clear that also. So, in today's session, we'll be going to see about how to handle imbalanced dataset. I didn't mention in the title. We'll also be seeing that. Okay, a small thing I'll be saying how to do that. We'll be seeing about feature selection. Okay, and train test split. Obviously, yesterday also we saw, but today I'll show it how to do in practical. Which model are we going to see today? I'm not going to explain the theoretical part. So in bootcamp, usually they don't do because if there are a lot of models, there will be a lot of explanation. I'll be implementing all the models and I'll be saying how to uh, like you know get the best model, how to choose the best model. We'll be seeing that today actually, because I'll also be saying about performance metrics, because today's session is kind of a long session. We are not going to waste any time. I think today it would be a 2 hour session possibly, because there are a lot to cover for me. And yeah, let's see how it goes. But one thing I can assure you is, at the end of this live session you'll be able to say okay, if this is the problem statement, I'm going to use this model. That's all. Simple. You'll be able to say that how to choose a model for a problem statement. You'll get to know that at the end of this session. I'm very sure on that. Hope you're all excited. I guess. Let us have a minute more. Until then, if you have any doubts, just ask it. And then, yeah, let's move forward. Today it will be a very fast session. Okay. So I'm not going to type a lot today, because feature selection, I'm just teaching it because you need to know that. Okay, but we are not implementing in the project. And coming to handling imbalance, I'll be saying the different methods, but I'll be teaching about the one method which is smart. Okay, smart will be applicable to most of the things which you will think of. For most of the problem statement, smart will be applicable. For feature selection, yes, I'm just going to paste the code which I have already in my Optimus project, and I'll explain the code actually. Okay, so if I type now today, it will be late, and then we won't be able to cover whatever I thought to cover till today. Okay, because if I cover today till now, till this today only, then we can move into some hyperparameter tuning, and then soon deployment also. So yeah, let's not waste our time. Okay. So as I'm going to share it from my GitHub, I'm also just note this one thing. I'm just copying this data set. Um, this data set, you might think why I'm giving it now, because I've pre-processed the data set completely as per our requirement. So yeah, you need not worry why I've given like this. So once you come to the project explanation, which possibly will be tomorrow, at the time you will get to know why I've given you this pre-processed data set. Okay, because I've handled all the things. Do we need to do all these feature engineering steps in DL2? Yeah, why not? It depends. If you're just doing a tabular data, this will be common to ML, DL, whatever you're doing. It will be this common. If it is image, based on image there will be different phases, and for text it will differ again. But if it is tabular, you need to do all of these steps for sure. So yeah, let's move on. Okay, so you can take the dataset from this link. Okay, this is the link. You can take it from here. Okay, I've also gave it in the chat. From chat only I'm pinging it. So just take it from the chat. So yeah, now let's move on with the basic way how we used to learn in daily boot camps. Right. First one, I'm going to talk about feature selection. Okay, we'll be talking about feature selection first. After that, I'll also be talking about handling imbalance. Okay, and then yeah, we need to do train test split, but train test split will be done before that. Okay, so once these are done, our whole pre-processing is complete. These are the, like, maximum. This is how you can do in any problem statement. Pre-processing over. Next we'll be doing the model creation phase, where I'll be, like, saying how to get the models. I'm not going to implement any of those, okay, because it will take a long time to execute. So I'm not going to say you how to, like, how I'm not going to run anything. I'm just going to run just two models, which will be very fast in running. I'll be just running the two model, and I'll be talking more on performance metrics, because by this performance metrics only you will be able to choose your model. Okay, so yeah, I hope today's agenda is clear for you. Okay, so let's move on with the session now. So here you can see, like, there is a lot today to see. That's why I said everyone to join soon, but no one joined. That's not a problem. So let's move on with the feature selection first. Again, for the question what, okay, we are selecting the most important, or else most contributing feature for our dependent column, or else dependent feature. Okay, so for example, there is one example I was saying before, right? There was a situation where I had 12,000 columns. I reduced it to half, to 6,000. I reduced it to 6,000 columns, though it was very high still, but 12,000 is way higher than 6,000. And by reducing this, I was able to push some 5 to 6% accuracy, solid 5 to 6% in accuracy. Okay, just by doing this one step, feature selection. Okay, feature selection is just to remove the unwanted columns, or else select the wanted columns. You can take it in both the ways. Okay, now why? Simple. Remove unwanted columns. That's all. That's why we need a feature selection, and also reduce number of columns, which means we are trying to avoid curse of dimensionality. Okay, so for this and all we are doing feature selection. So one thing, another thing is possibly to increase accuracy. Okay, so these are all the reasons for doing feature selection. Now the different methods to do feature selection: Pearson correlation, variance, chi-square, model based. Okay, these are the main four methods where we'll be using, from this only we'll be doing feature selection. Sorry, the question was on feature scaling before train test split. Okay, so you have another question here. So do we need to do feature selection before train test split? What if the scale max values are improved in training set and mean values in test set? No, no. Yeah, we'll be doing feature scaling before only. Like, if it is scaled, you need to scale in testing set also. Whatever you are passing it, even if you are getting a value in real time through Flask, then also you need to scale it. Okay, after scaling only you can put it into your model for prediction. Unless and until you should not do that. Okay, so yeah, you are correct. Feature selection must be done before. Sorry, not feature selection. Feature scaling must be done before train test split. Okay, so yeah, here some of these expect to have train test split. Okay, some of these expect to have train test split. So now let's move on with method by method. Okay, so I'm going to take my GitHub code itself. Okay, because I'm taking the code today is to, we are having lot of topics and I need to talk about feature selection. I need to talk about imbalance handling. Okay, I need to talk about model creation. I need to talk about performance metric. So today I'm just going to take the code. I know you all preferred live coding, but yeah, I'm just going to take the code today. Okay. So there is my Optimus. So if you need the file, just put it in the chat. I'll also send that. Okay. Where is it? Ah, here it is. So yeah, here it is. Okay, see here, guys. These are the types which is available. Okay, so you need not worry. I'm just going to debug it. So don't worry about what is written here. Actually, the line might be very large. Okay, but it is just a template. Okay, so time to create a new file. This is our practice, right? So it will be feature selection dot ipynb. Okay, so let me do import numpy as np, import pandas as pd. We might not need it. Okay, so let me do import sklearn. Now it's not giving any suggestion. So let me just check if it is installed once, because I have uninstalled my anaconda for some reasons. So yeah. Let me check once. Okay, now it's installed. Okay, okay. Yet to get the file. Which file? Could you post? Okay, which file? Which file? Code file or else the pre-processed CSV file? Because if it is a pre-processed CSV file, I have put it in the chat already. Okay, you can see it above. It is given. But if it is the GitHub file, I'll give it now. So just say which file do you need. Code file. Okay, you can go to my repository actually. Okay, here it is. Just copying it and then I'm pasting it here. Okay, it is given. Okay, it is given here. You can just have a look onto it so that you can copy paste it like what I am doing here. So first things first, to read the CSV file. So let's read it. Okay, so anyway, this was one of my previous works. So I'm just going to check if there is any null values. Okay, it's not there. Df.d types. Okay, the first one is alone object. I'm going to remove it for sure. So not a problem then. Df dot drop of um, I think it should be date. Yes, access equals. Why is it like this? Now it should work. Df. Okay, looks fine for me. All right. Okay, looks good for me now. Okay. Please proceed coding along with you. Awesome. Just code along with me. Awesome, awesome. Now for feature selection. Okay. I've copied a different thing. So don't worry, when I'm copy pasting one method, I'm just going to explain that method also. Why is it not copying correctly? Okay, so here if you see what will happen is we'll be setting a variance threshold. I hope you all know what is variance, right? How much the columns are varied in between that. Okay, the first method is variance threshold. It will try to check the variance between the columns, and we need to set a threshold, and we need to set a threshold of variance. Okay, it is just based on how much varied is the column. That's all. Nothing more than that. Nothing to be complicated. Okay. So here, if you see, I'm just giving a threshold, right? So based on that, it will fit it. Okay, it will fit the whole x column. X is like our dependent feature. So what we can do is x is equal to df dot drop off. I don't need price. Why do I need price? Rain tomorrow. I've written rain tomorrow, and y would be df of rain tomorrow. Okay. So before into feature selection, I'll also do train test split. Okay. Um, scale learned on model selection, import train test split, X train, X test, Y train, Y test. I'm just doing a train test split here. Okay. So yeah, now for running it, I'm also using Stratify so that it will select in a correct way. Okay. It is a parameter only. You need not worry. Okay. So I hope you all done this step also, which is train test split. Could you please repeat about variance threshold? Okay, will do. See, I think you all know what is variance is. Like x minus x dash the whole square summation. That's all. Okay. So this is variance between two columns actually. X minus y, x to y actually. So you can check a formula in the internet also for this. Okay, so it will calculate the variance between the columns. Based on that, we'll be setting a threshold, and if it is less than the threshold, it will be removed. Okay, so yeah, now for running this. See here, I'm just making a variance threshold. I'm importing it from sklearn. I'm setting a threshold. Okay, and I'm fitting the threshold selector on this x data, which is our training data. Okay, and then what happens is the selected columns will take the support of, so get support. What it does is whichever column is passing this test will be true, otherwise it will be false. So we'll be taking the true columns alone from this. Okay, so for this true columns, we'll be taking it as selected columns. For all the false columns, we'll be taking it as removed columns. So once you have got the selected and removed columns, we'll be making our data set just with the selected column. Okay, so that's why variance threshold is done. So yeah, not a lot to talk here because I'm not focusing on variance threshold a lot. Because what can I say is actually variance threshold is not used in real world a lot. Every time we used to go for a model based approach. Now I need to take some copy. X is equal to x1 is equal to x. I think I might also need another one. I need 4 x because for a simple reason. Okay, need not worry on that. Now for variance threshold implementation. Variance threshold of x1, and I'll set a threshold maybe to 0.8. Okay, so let's see what is it happening here. So the column selected are these things actually. So do you want to remove the low variance columns in the data set? Yes. Now, if we see x1, let's see what has happened. Okay, just a minute. It should have changed. Okay, let me see if s is only given here. X is equal to x selected columns. What is the selected columns? Okay, the columns selected are these things. Removed is only these things. Rainfall and rain today. Okay, I have just written a wrong message here. I guess then. Yeah, correct. So just don't get confused. Okay, remove removed are. Okay. Just give yes. Okay. Now if you see x1, there is 23 columns. Actually, if you see X, I think it should be 25 columns. Then. Okay, it is also 23. Why it's not removed then? Number of columns removed is 2. Just give me a minute, guys. I need to check it actually. Actually, usually it works. Just a minute. What is the output of variance threshold on get support? As I said, like if it is passing the test of variance, it will be returning as true for that column, and if it is not passing, it will be as false for that column. That's all. So if you want, we can print it actually. Um yes, let's do that also. Why is it not working correctly? Uh, 0.1. See here, everything is true now. As I have said this, it is now everything true actually. Okay, so maybe I'll set it as 2. Okay, let's see what has happened now. See, there is only one false here and then another false here. Okay, so there are two false. The columns removed are these. And do you want to remove the low variance columns in the data set? I'll give it as yes. Yeah, okay, it has worked. Okay, so yeah, cool. Now let's move on to the next step. Okay, so which is uh, it would be Pearson correlation. It is just to check the Pearson correlation. That's all. Nothing more than that. Okay. It will not do any other things. It will just do Pearson correlation and it will execute that. Okay. I'm just going to say that also. I'm just going to explain this call. Structure. This would be again like you'll think okay this is very huge, but if you just see it will be like a repeated thing of that. So first I'm taking the correlated columns as a list, an empty list. Okay, and I'm taking the correlation matrix. X dot correlation will return the correlation matrix. Now what I'm doing is I'm just taking the features as a list. Okay, like that columns I'm converting into as list. So once it is done, I'm just taking the range of correlation matrix dot columns, like how much columns are there in this correlation matrix. I'm just taking that range, and in the j of range of I, because it will be one above the other, like x and then y, it will be like a two-dimensional, right? So to pass into two dimension we need x and y, and then we'll be doing absolute is what we'll be using it for correlation check. Okay, so the absolute correlation matrix of I of j, if it is greater than the float of threshold, then we'll be taking it as correlated column. That's all. Okay, you need not worry on this and all. We are just checking the correlation, and if the absolute value, which is like for example, what I can say as absolute value is, I'll show you an example here. It is here. It is ABS in Python. See here. For example, if the ABS of -9 would be 9, that's all. It will not return any negative. It will just return a positive, which is like a distance. How much value it has difference between zero. That's all. Other than that, it will not do any other things. Okay. So don't need to worry about these and all. Okay. These are all just kind of what I can say is like you need to return X also. What I can say is, these are not going to be important because we don't use these really. But I'm just saying, these are all methods available for you. See here, Pearson correlation of x2, and I'll set the threshold as 0.7. Okay. You want to remove the correlated feature? Yes. We have removed 7 columns actually. Okay. Now, if you see, actually, I should take 1, 2, 3, 4, 5. Okay. So let me do that also. A, comma, B, comma, C, comma, D, comma, x2 equal to. Now should be fine. X2. I'm returning it actually. So let's do x2 here. So previously that's why the change didn't happen. Okay. So now it will happen actually. So positive difference. Yeah, you can say that. So you can say that. Okay. How much distance it is between from zero. That's all. So you can say it as positive difference. It is also a term which you can use. I don't know why this much long. Previously it gave so faster. I don't know why it's taking this long. Okay. I think it should be five. I guess. One, two, three, four, five. Five only. Yeah. Why it is taking this long? Maybe I'll wait for a minute. I don't know why literally it is taking this long. So let me stop the kernel. Possibly it is taking a long time. Okay, I didn't remove give yes here possibly. That's the reason. I didn't see it. My mistake. X2. Yeah, here you see 18 columns. Okay, it has worked. So just return is from this function. Okay, and just call it like this because we are having 5 written here. Just put 5 variables so that you can call that x2. That's all. Okay, so we have removed some 5 unneeded columns, not at all needed that columns according to this Pearson correlation. Okay, so yeah, now let's most correlated features will be removed, right? Yes, if they are multicollinear, it will be removed. I think Pearson correlation is good for feature selection. No, I don't accept it usually. See here, one of the most important feature is rain today. It's now removed. Okay, actually, I don't prefer feature selection when we are having just 20 or 25 columns. That's why I didn't even prefer feature selection in our project. Our project doesn't have feature selection. Okay, so don't do feature selection unless and until it is needed. Okay, now for the best method which you can prefer, which is model based method. By using select k best, we'll be doing that. Okay, so here it is lasso for linear regression based model, and logistic for classification based models. Okay, so I'll execute both of those, but here we can't execute lasso, so I'll be executing logistic. Okay, what I need to do is we need to have just 1 minute logistic selector support. Okay, now it will work. Let me run this one. I think this should work. Let me do logistic select from model x2 y. We don't need this x2, not x2. I need x itself. Why not? How much feature I need? I need 15 features. Okay. Now if I run this, let's see what will happen. Okay, I'm not going to return any of these. I'm just going to return X. So I'm just going to change it as X underscore maybe log. Okay, let's see what is happening here. Okay, total number of iteration reach limit. So the number of columns removed is 14. X underscore log. I'll also print it. So it will take some time. Do you want to update the features on the dataset? Yes. Here. Okay. We have removed it. These are the columns which are available for now. Okay. So yeah, that's what is the good thing about logistic regression, because we are literally fitting it with a logistic regression actually. Okay, it will just check which is the best model with logistic regression. So that's why I prefer model based. It's not like logistic regression, you can use any model you want at that place. Okay, so these are all the feature selection methods I would suggest. Okay, so yeah, now let's move on with the next step, which is imbalance handling. So shall I move on? So you need to only say, you need to confirm. Okay, like feature selection according to me is an important step, but not important for our project. But yeah, this is like there might be some other methods also, but the most best method you can do is by using this model based method. See, what I'm doing is I'm just calling the select from model and I'm calling this regression. Okay, I'm just in that select from model, just give your model name first and then give the max features equal to the how many features, number of features you need. That's all. Then put it, get the support, and based on the support, as usual, create the columns which is needed. Remove the see the removed columns, whatever it is, and just update the data frame. That's all. Okay. So yeah, I'll wait for a minute to answer your query. Okay. After that, we'll be moving on to um, feature extraction. I'll talk about that, some things. Okay, for maybe 5 or 6 minutes I'll be talking about that, and then we'll be moving on to handling imbalance. So once this is done, we'll be talking a lot on model creation action. So yeah, just put it in the chat your doubts. Yeah, now why model selection? No, why model creation? No, first I need to explain you about how to handle imbalanced data set, why it is needed, and then I need to say what is feature extraction, though we are not doing it in this project. I need to talk about that because that might be needed for you at times. Okay, there is not any specific methods to create features. I'll be just saying an overall idea on what is feature extraction because at times it might be useful for you at the later part. Okay, so yeah, let's do that in a short 15 to 20 minutes now. Okay, so yeah, first for feature extraction, there is only writing for this, no hands on. Okay, the purpose is to, so I'll first answer why for this. Okay, to increase the number of features which are important with respect to the output feature. Okay, so for example, yeah, bank loan. Okay, so there is a data frame. Okay, there is only three column, which is age, name, and then um, bought loan or not, something like that. Bought loan. Okay, now based on this age, you can create a new feature, age bucket or something like that, because this will increase the feature important. How it is? See, usually loans are bought by the age people around, like, 31 to 40 and 41 to 50. This is the two age range which is highly bought. So you can just, like, create a bucket like this and then encode it as 1 and then encode this as 2. By this you are adding some extra importance. So if you check the correlation for this, it will be very good. Very good correlation will be there with respect to the output. So I'm just assuming that 31 to 40 will be good, but you need to check with your data, because data is the thing which is going to, decide which you need to do. So just do with the data, don't go by your heart. Okay. So that's about feature extraction. Very simple. This is what I wanted to say. Like, you need to make features out of this. For example, if you are having 3 to 4 features, age and then, like, your salary. So based on that age and salary, you can create a new feature. Okay, so with this age and this kind of a salary, he's like, suspected to do, get a loan. He's suspected, or else, like, prone to get a loan. You can just create a new feature like that. Okay, so these are all some ways you how you can extract some features from the existing feature. Your screen is not visible. Oh, sorry. One basic question: is our data not model ready now? No, our data was already model ready. Whichever data I've sent you before as pre-processed one.csv, it is already model ready. Sorry, I wasn't sharing my screen. Okay, so I'm just showing this now. Okay, I think I have explained it. So anyway, I'm just going to re-explain it. So to increase the number of features, what we are doing is we are creating a new feature, or else we are extracting a new feature from the existing feature. So as I said, one example is if you are having age, name, and then loan, but 0 or 1, like, bought, not bought. So usually the age range of people having from 31 to 40 or else 41 to 50 is highly prone to buy a loan. Okay, but what will happen, like, if you are having another feature and you can give importance there also. For example, your salary. Take that you are a guy who is having 2 lakhs of salary. Okay, why will you go for a loan? You won't go, though you are in that age range. So you can also make a filter by that and then create a new feature. Extract a new feature based on the existing feature. That is feature extraction. Okay. Is feature extraction equal to feature selection? No, how it will be? We are extracting a new feature, right? Like, we are adding a feature, we are not reducing a feature, to be very specific. At a shallow level, we are adding a feature here in feature extraction. So yeah, it is not about feature selection. No. So yeah, that's about feature extraction. Next, we'll be having imbalance data handling. There are a lot of methods actually, but I'm just going to talk about three methods, which is upsampling, okay, downsampling, and then smart. I'm just going to do the hands-on only for smart because this might take time, okay? And we don't have a lot of time. So once we are done with this, I'll create a model and we are going to talk very extensively on performance metrics because that is the most important thing you need to know because this is just a line of three line of code. That's all. Three line, literally three line of code for any of these upsampling, downsampling, and smart. Okay. So upsampling is to just increase the data in a category. Just a minute. Increase the data in one category because we know that the rain tomorrow for column we know that it was imbalanced, right? It was very imbalanced that tomorrow it is not going to be rain. Yes, was having very less, so we'll be trying to increase this also to manage to this level. Okay, that is called upsampling. Downsampling, this is the least preferred. So how we can prefer is first smart, second upsampling, third is downsampling. There are some other ways also, like you can do clustering, and based on this clusters generated, you can generate new data from that cluster. But for as I said, this is a beginner bootcamp, so I didn't want to involve advanced concept and all. Okay, so for now, just focus on smart. Smart would be the best method I will suggest. Okay, so yeah, now coming to downsampling, it will be it will try to reduce yes to the amount of no. It will be in the same level. Okay, smart, it will be taking the k neighbors and based on that it will balance. You need not know the technical side of imbalance handling. Okay, it is not going to be asked anywhere, like, or else you don't need to actually literally dig down on this a lot. Just that smart is going to be the best method that you need to do. Okay, so I'll be just showing you now. That is also there, but not in this folder. It is in a different repository. So yeah, today I'm slightly rushing up because these are all our concepts which there needs a least understanding actually, because these all what I will say is always it is going to be constant based on the data is not going to change. Okay, always the feature selection method is going to be the same, or else the feature extraction method it's upon you. Imbalance handling, it is also upon not upon the data, it's just upon which method you are preferring, that's all. But previously when we were saying about pre-processing, there were a lot of methods and it was upon you and the data. So for example, the transformation which we saw yesterday, it depends from column to column, right? For one column there might be a good transformation, for another column there will be another transformation. So that's why I'm not focusing a lot on today. Okay, today our main focus is just to move on with the model creation and its performance metrics so that we'll be choosing the best model. Okay, do we have any random sampling here? So what do you mean by random sampling? Can you please say what do you mean by random sampling? So until then I'll answer your another question. Okay, so what is that synthetic minority oversampling technique? Okay, synthetic minority oversampling technique. So what it will do is it will synthesize the new data. It is not taking from existing data, it will synthesize the new data on the minority column based on the existing data, randomly filling values to balance the data. So yeah, that can be done, but it's not going to be happening, in oversampling. Yeah, it will happen. It will just take the random data and it will again increase the column, or increase the node there, but it will not create a new data. But smart creates a new data. That's why it is called a synthetic minority oversampling technique. Okay, you are getting it. Oh yeah, yeah, great. So let's do Let me show you alone, okay? Because there is not a lot to run and all here, okay? End-to-end handling imbalanced. Okay, for imbalanced have kept a different thing. Okay, here it is. Okay, so if you are doing undersampling, just actually you need to install IMBlearn. Okay, so just import from IMBlearn that undersampling, import near miss, and then give some percent. How much percent of value you need to correlate? For example, I am here saying, like, 80%. It should be 80% alone different, not 20%. Like, here now in S might be 30%. So we need to balance it almost. Don't give it one. Okay, it will become 100% equal. Like, 438, 438. So don't do that. Just give 8 or 9. 0.8 or 0.9 should be better. This will be undersampling. Now for oversampling, just like, from IMB learn, import over random oversampler. That's all. Again, same thing. As I said, just three lines of code, nothing more than that. So that's why I said here, like, we need X train and Y train, X train or Y train. Okay, that's why I said just do X train and Y train. Okay, so smart atomic and smart both you can use. Okay, similarly, that is also going to happen from sklearn, see, IMB learn, imbalance learning. Okay, that's what name has been shortened as IMB learn. So from there, I'm importing smart atomic and then I'm giving it as 0.75. Simple. That's all. So as I said, like imbalance handling, it's not a great deal. It's a very, very simple task. Just a two line of code, not more than that. Because it is going to be stable, we are not going to write any new function. So even you'll see, like, model creation is similarly like this only, because model creation isn't that tough actually. To be very frank, it is one of the easiest phase. But model tuning, it is going to be a irritating phase actually. Everyone will think, like a pre-processing phase is the most irritating phase, but according to me, model creation phase is the model tuning phase is the most irritating phase for me, because what will happen is you won't have the good computation resources, so it will exit the loop. Actually, whatever loop you are performing, it will exit it. Or else another possibility is, just a minute, you will not get your expected result in some loops itself. So that will also at times irritate a lot. So model tuning, it's one of the most irritating phase. So yeah, actually we are marching towards the end of the bootcamp actually. So because already we have seen all the things, whatever you need to do before creating a model, we have seen everything. Though some things are not used in our project, I have implemented everything. Okay, I've shown you. Yeah, today's session is kind of a rush up session because these are not very important, though it is an important phase, not as much important as the previous one, because um, there is not a lot to learn here. That's all. Nothing to be thinking, like, just go implement smart. That's all. I don't prefer oversampling or undersampling. Straight away smart. A complete feature engineering, it was wholesome. Yes, it is a complete feature engineering. I completely like, compiled everything literally. Like, I'm sure of one thing is, like, you won't get a bootcamp like this. If you pay even if you pay, you won't get this kind of a bootcamp. I'm very sure on that. So yeah, I'll take maybe a 5 minutes of question, like whatever it is in pre-processing, whatever till now we have seen. It's a lot actually. It's been 6 days. I've taught you. So just take 5 minutes of questions. Like, there is only two members here, but according to me, even that two members is very respectable. So yeah, if you have any doubts till now in that 6 days, whatever I've taught till now, just ask it. Whatever related to pre-processing, just ask it, and then we'll be moving on to model creation, because till now it is a 70% work, literally 70 to 75% work you do in real time. Model creation, according to me, it's just 5%, 5%, not more than that. And then it will be more focused on deployment and model retraining. Sweet, thanks. Yeah. Yeah, I'm open to questions. So whatever question you have, just fire it up. We're having 4 minutes now. Okay. Once it is 1 hour completed, next half an hour or 1 hour will be on performance metrics and model creation. Model creation, it's going to be very simple. Okay. You can even get it on Google itself. But I'll be talking on performance metrics actually, because as I said before, at the end of this session, you should be able to say like, no, I can select a model. I'm very sure on that you'll get that. Okay. So yeah, I'm open to questions. You can just fire it up. Any questions? Tanlakshmi and I don't know who is the other person here. Yeah. Okay, your screenshots. This dataset is this dataset is not imbalanced. Can you say about some use cases on next? No, our dataset is imbalanced. I shown you in EDA, right? The first day of session. Oh, the second day. Yeah. In second day, I show you, right? It was imbalanced. Did you see the graph or not? S was very less and then no was very high. Our data set is imbalanced. For example, credit card fault. Okay, there is a very less chance to have a fault credit card. So that is also an example of imbalanced data set. Wherever you're seeing that there is an imbalance in, usually imbalanced data set thing will happen in classification only. I mean, it's now pre-processed. Yeah, it was not pre-processed. Now only I pre-processed it, right? But that small comic, whatever you seen, I'm just implemented here. That's all. Actually, when we are seeing the project, you will get to know. So if so, can we apply SMART in the old dataset? Which dataset? So, see, scaling can be applied once you do, all the pre-processing. Your missing values handling, your categorical value handling, outlier handling. It's upon you. It's not a compulsory step. So the first two is very important. Without that, you can't move. Missing value handling and outlier is not important. Missing value handling and categorical value encoding, both of them are must. If you want, you can do outlier handling. Then a train test split, if needed feature selection. Then your imbalance handling. If there is an imbalance in the output feature only, just an output feature. Okay, you'll get to know. Okay, you'll get to know. We'll be seeing the whole project, right? Maybe I think tomorrow we'll be seeing the whole project, because tomorrow will be slightly giving you a glance of the whole project, and day after tomorrow, Ritesh will be up with us. I will be coming. So if he's coming, he'll be teaching about hyperparameter tuning. Okay, this data set I can do hyperparameter tuning because my system doesn't have that good computation to do hyperparameter tuning for 2 lakh rows. Okay, so I didn't do hyperparameter tuning basically. So Ritesh will do it on a simple data set. So once that process is also shown, we'll be moving on to model deployment. So yeah, tomorrow will be my last class. I'll say tomorrow is my last class. So after that, Ritesh will be taking over this bootcamp. Actually, I don't know if you are typing, but I'm not able to get any messages. What is the least configuration expected in such case? Oh, no, it depends on the data. Like, even my configuration is a good configuration actually. So at that time, it was 8 gigs RAM, 512 GB SSD, 1 TB HDD, and I had a graphics card. Everything was there, but yeah, it's tough. So, how many days of bootcamp have you planned? Actually, I planned for 5 days, but I wanted to cover it very extensively. So, yeah, I'll take another day, right? Ritesh will be taking 2 or 3 days, so you can expect a 9 to 10 days bootcamp. 9 to 10 days will be sure. Yeah, because tomorrow will be, as I said, my last day of session. So Ritesh, he'll be teaching something about hyperparameter tuning, the basic things, all. Okay, what is hyperopt, what is optuna. There are some libraries to do hyperparameter tuning, and the most important thing is randomized search and grid search. Okay, so he'll be talking about that in the session, sometime for some time, half an hour, something like that, and then he'll be moving on with deployment. I don't know how long he's planning. He said around 2 to 3 days, but it might extend, or else there is very less chance to shorten because he's telling that he's going to talk about MLOps to me. Okay, he's a great guy. He's the best person you can have for talking about MLOps. So he said, I'll be talking about no issues. I'll be talking as in such a way that beginners will be able to understand. Okay, so yeah, and guys, so as you are here, I think Dhanlakshmi, you are the most luckiest person. You'll be getting to know this. Tomorrow's when I'm going to provide the certificate link. Just register it, finish. Shall we have a quick recap of all topics covered so far today? Do you want now a recap, or else shall I have a recap session tomorrow? Anytime. Okay, let me have it on tomorrow session. Before going into the whole project, as we have talked about, we are not we have we are going to talk about the performance metrics and model. I can't again revise it. I can't revise it again. So totally, I'll be revising it tomorrow. Maybe in first maybe 30 or 20 minutes. I think it's more than enough. Okay, I'll be just saying what are the process and what we do. That's all, very simple. Maybe in first 10 to 15 minutes, and then we'll be going to the projects. So I don't know, you'll be very happy that okay, I attend the bootcamp correctly, man. Because of that, I'm very happy now. You'll have this feel because I've done an end-to-end project, and you'll think bring it, yeah. If hereafter I'll do end-to-end projects, very simple. Bring any project to me, bring any machine learning project based on supervised learning, I'll do it. I'll bring to that position for sure, because deployment, Ritesh is going to take it. I'm very sure that he'll be doing his part correctly, and I'm sure that I've done my part correctly. But I'm it's upon you if I've done it or not. If you are thinking I've not done, just put it in the comment section, or else put it in the Telegram group, or else in the live chat, wherever you want. Just say Vasant, you have not done your part correctly. Just you are missing this or that. Just put it. I'll just rectify it. Not an issue, because human makes mistake, so I also make mistake. So yeah, you are a great instructor. Thank you so much. That's a good thing to have, that I've been saying as an instructor. I never had a problem of talking with others and then helping them, because I've been a part of lot of communities before this also. So yeah, let's move on with the model creation phase, which is I think the most interesting phase for everyone who is watching this. Your teaching made me to attend everyday session. Really, that's great to know. Uh, thank you for the kind words. That's really that means a lot to me. What's the plan for tomorrow? Sorry, I joined late. How you're correctly joining when you joined at the perfect time actually. I was saying that like tomorrow we are going to implement the whole project because till now I've explained you each and every phase, and next I'm going to talk about the model creation phase, which I think is the most interesting phase according to you all, I guess, but not interesting for me. So I'll be talking about that, and performance metrics will be completed. And in tomorrow's session, I'll be providing you the certificate link where you can write whatever you want. I'll provide a Google form. Okay, so you can write your feedback there. Maybe if needed, if I think it's needed, I'll just give you some two or three questions. Okay, some technical questions for sure, and you can also answer that. And then yeah, I'll give a certificate based on that. Okay. I hope you got the point, Babu Button. So tomorrow's plan is that only, to implement the whole project in one session. Because till now I explained every phase, so I need not explain a single thing tomorrow. You'll be thinking like this is a very cheap stuff for me. Why wasn't there you bringing the cheap stuff hereafter? That's how you'll feel because yeah, I've covered literally everything. Because once you complete this bootcamp you can claim that I'm not a beginner yet, I'm an intermediate machine learning engineer. You can claim that for sure. But yeah, you need to learn the theoretical part of the ML model. If you learn it, you can claim that you are an intermediate machine learning engineer. So yeah, let me share my screen. Okay. So one request, guys, I'm requesting it every day, but yeah, slightly it's coming. Just share it with LinkedIn is one of the best source. I think a lot of people are there in LinkedIn. Just put it in a LinkedIn post, there is a bootcamp going on, so there will be a lot of persons watching this. Okay, so just tag me there. Okay, tag me in the LinkedIn post so that I'll also be having a look because I just want to reach people, nothing more than that. Okay, I have no intention of getting money of this. I have intention of just reaching more people and then giving more help, that's all. So yeah, help me do that, help me reach 500 soon. I'm at 260 or 263 I guess now. 263 subs around that. And yeah, help me reach 500. Yeah, Ritesh is here. Ritesh, hello man.
Yeah, hello everyone.
Yeah, Ritesh. I said tomorrow's plan also, where that you are going to teach about hyperparameter tuning, and will also be providing the certificate link. Both of them. I just said that this is the tomorrow's plan.
Okay, 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 okay.
Yeah. And Ritesh, what do you think? What do you think about deployment? They are asking how much days it will be this bootcamp because tomorrow I'm just going to hand over this bootcamp whole bootcamp to you, and hereafter is going to be your bootcamp where you'll be teaching about hyperparameter tuning and deployment. How long it will take? A rough estimation.
Yeah, see, hyperparameter tuning is not a long thing. We can just have a basic model and like random forest or any model, and just we can tune it using grid
Yeah,
search or
yeah.
randomized search. It will it
Okay.
will hardly take. Yeah, you are saying something, Basil?
Yeah, deployment.
Yeah, for deployment, I will show you onto the uh, I will show you the basic layout, how you can deploy to AWS and how you can Dockerize a project. And I guess you know Heroku. If you don't know Heroku, then we can also have it. So till we can have 2 days. Like we can consider 3 days for it. For
Okay.
MLOps, 1 day for MLOps, like for all the ML operations, how the pipeline works, and the another day just some basic introduction over how we can deploy to Heroku or AWS. These all.
Okay,
So
guys, do
three
you
days.
need
Three
about
days.
Heroku or AWS or both? Just put it in the live chat now itself. And
I
guys who are
guess
watching us recording, just
yes,
put it
yes.
in the comment section so that we'll get to know what you need, Heroku or AWS or both. Because based on that, he need to plan your session. Don't know Heroku. Okay. Heroku then will be covered, right, Ritesh?
Yes, yes. Hirko will be covered. Hirko will be covered.
Great.
Okay,
Yeah, guys.
Hirko will be
So
covered.
okay, that's
Okay,
great.
but you should have a basic understanding. I hope so. Like you should have a basic understanding of Flask, just a basic understanding, because Flask is important. Like for that, we will see Flask, but you should have a basic understanding. I guess like just take a look what
Please plan after the festival. Actually, we are having a long session on Friday because, like, that's the day when we both are free. Actually, uh, so let's see. Like, possibly
Okay, so
even
what we can do? We can plan according to the audience. So we will see. We will see. We will update you.
yeah.
Okay.
So yeah, like, if it is needed like that, then we'll plan the session on Saturday or Sunday. Not an issue. We'll like postpone the session, but if it is on Sunday, we'll try to plan it on morning sessions because at afternoon he's busy and night I'm busy, so we'll be having on Sunday morning. So yeah, we'll see the audience suggestions actually, because if it is festival, I know you all have, like, all of us will be celebrating. So let's see on that, not an issue. Okay, if needed we will just postpone to the next week also, not an issue.
But it's depend on you. Like if you're
Yeah,
getting everything, that's the way. We don't want to like make the session fast, like make the bootcamp fast, like we need to complete it like in hurry. We don't have any kind of a hurry. We can have a split. We can split the sessions in multiple days. So it is upon you. Like you should know, you should get to know like everything, like what we
yeah.
have decided here.
That's what I was saying. Like, no, Ritesh, right? We were planning this bootcamp just for 5 days actually, and then yeah, we extended this to 9 to 10 days now.
Yes, yes, yeah.
Yeah,
So
like,
it's great. Like if you
to
know know the basics of Flask, then it will be fast, like little bit fast. Actually, it depend upon the audience, like how the audience know what all things audience know. So if audience know Flask, then we don't need to like work on like explaining each and every line of Flask. But I will do that. I will write comments. I will write there like what these all things are doing, so that you can have a basic understanding about it. We will deploy to Heroku and we will see a pipeline for AWS also at the end. We will not deploy to AWS, but we will see how you can do that at real time. And that all will be covered in MLOps. Like we will have a basic, you can say introductory session on ML operations, like why we need it, what are difference between DevOps and MLOps, everything. Don't worry about it. But it depend on you. If you all want in a particular day, just suggest. Then we will also check our availability and let you know.
yes, because without persons in live, I don't think what we are going to do in live. Okay, so yeah, it's upon you guys. And the guys who are watching this recording, be sure that you're joining tomorrow because tomorrow I'll be forwarding the certificate link. Okay. And yeah, now let's move on with the model creation because Ritesh has made his announcement of what he's going to do. I hope you are all happy with this announcement. Okay. And now I'm going to do model creation now. Okay. So yeah, this is kind of interesting one for you all. Okay. First creation. Okay. So how we'll be creating is, first things first, we need to check what is the type of ML problem statement we are having. Okay, so is it supervised? I'm not going to explain what is supervised or unsupervised because I have done it in the first session itself. So I'm not going to explain that at all. So I'm just saying what is the types available, or unsupervised, or reinforcement. Reinforcement is just an approach. Okay, so don't get worried about the name and all. So we need to check what of these we are going to do. Of these, there are types here like, regression and classification. Clustering, associate rule learning. Okay, so of these, associate rule learning is just to make a recommendation system. Okay, I hope that also I mentioned in my first session itself. So you need to check which of these is there. Okay, by this you are getting to know halfway of which type of model to choose. Should I choose a regression model or a classification model or a clustering models or a like, kind of a recommendation system model? What I need to choose first step. type of model. Okay, next step is models available in that type. So type of model and model available in that type. So it might be confusing for you, but I'll say like for example, in classification, I'll say whatever I know or else I have heard till now. Okay, so we are having logistic, KNN, SVC, naive bias. So next we are having random forest, gradient boosting, XGB, cat boost, light GBM. Okay, these are all some models I know for classification. Yeah, so this is the second step. But what we will be doing is, why I'm saying to check for all the models is, we'll be trying to fitting up all these models to the data. So you might think like, Vasanth, what are you saying, man? Like that you might be confused. Okay. See, initially we can make a lot of assumption. Like for example, when I was doing this project, I made an assumption that SVC will be performing very awesome. And yeah, it was performing awesome actually. So you can make an initial assumption by doing a good EDA. You'll be able to make a assumption at initial day, like at an initial times itself of our project. But always implement all possible models by yourself. Like there is another thing called extra trees classifier. I just left it. Extra trees, and finally the last but not the least, custom ensemble. Okay, these are all some types of models which is available. So and then deep learning is also there, you can also go there if you need. Okay, just fit all of these models to the data. And third step, check performance metric for each type of data model. Okay, each type of model, just check your performance metric. So are you clear with the steps? First things first, then only I can explain each step. Actually, first step I need not explain, type of model is not needed. And model available in that type, you can just research on those, but I need to explain this very much clearly. For that, you need to just understand the overall concept, whatever I say till now. Yeah, so like just say, are you understanding it? Please go ahead. Awesome. And the one thing to say, like I'm just giving us a maybe alert or else a suggestion, whatever you want to take. Whenever you're going for interview, there will be one common question usually asked by interviews. Common question, but not the always question. Like it doesn't like that. But usually they ask like what is your favorite algorithm? Okay, just say any algorithm, that's fine, but be sure that you're checking, you are knowing the complete part of it. But if they're saying, if they are given a this kind of problem statement, which algorithm will you choose? Okay, at the time you say that I'll be implementing all the algorithms, and which is performing very well in that data set, that would be my favorite algorithm for that. This will be the best answer you can give, because they won't be able to ask anything to you. They'll ask like usually they ask, for example, if you are saying, for example, my favorite personally is support vector machines. Okay, due to its working, I love support vector machines a lot. If they ask favorite, I never say support vector machine. Okay, I say like if which algorithm is performing very well in the data, that is my favorite algorithm for that data. But if they ask me like which is your good strong model, or else like which model do you know well, then I say about SVC, because they can't ask like why I chose that model for the data. Okay, so always be sure that you don't give a chance to the interviewer that they're having a point to hold you. Just say like I'll be just going with the performance metric, and which data gives the best performance metric, that I'll use it. Simple. Okay, so Ritesh, are you accepting this point? Uh, this is kind of a point I think I am right according to me, but yeah, I'm not right according to everyone, right? So Ritesh, your opinion?
Yes, yes, yeah, yeah. That's true. Yeah, true. Yeah.
Which model performs well in large data
See,
sets?
see, see, see. This question, this. Wait a second. There's disturbance.
Yeah, actually, this is a question I used to face a lot. I
Yeah,
hate
yeah.
this
See,
kind of thing.
see. This kind of a question, you can say like there is not any perfect model. In supervised also, there is not any perfect model. You can say, uh, even if small models can sometimes fit better on, you can say, on a big data set also. Like you always try to start with logistic regression. Just start with logistic regression and then move forward with trying like different models. Let's say you have taken cat boost and you don't get any good result because these are some kind of a heavy models. These are used some state of the art, you can say, results. They have given state of the art result, but they sometimes not fit on that large data set. So what you can do, you can start with small models and then see the performance, or
Actually,
you can.
Ritesh,
Yes,
yeah. Actually, Ritesh, the interesting point is logistic regression was the third best model performing on this dataset, though it had
yes,
two
yes,
lakh
yes.
rows.
Yeah. So, yeah, so it is there. Like you can see like these all models, like small models, sometimes work very well. I've seen many times. Like not only in machine learning, but also on, you can say, in NLP also. In NLP we have a lot of big models, big models released by Google, Facebook, and Fast AI. But at the end of the day, if you start with it, you have researched a lot. Like I have experimented a lot onto that many models, but at the end of the day, I have came to know like the basic
Which
model
is
is working
practical
best.
ST.
Yeah, the basic model is working best. Like it is, you can say, surpassing that big models, like in the point of accuracy and these all. I'm doing a simple text classification task. That large model are, you can say, finished in front of these small models. So it depends from data set to data set. We can't suggest any best model, but you need to experiment. This is experimenting. The more you experiment, the more you get. So that's it, like from my side. Like anything you
Yeah,
want to
yeah.
add on?
No, actually, this would be my suggestion also. Like, no, always go with from the basic model because everything is built over the basic model, right? So there will be something on that model, though it had lot of problems. There will be something on that model. Just experiment it with, because that's why I said, right, never ever fall into the trap of favorite model question. That is a good trap used by interviewers, like, to hold you up, like, favorite algorithm or else the best algorithm. It's like, your go-to algorithm. There are different ways to put that question, but say, like, be very smart in saying, like, that time they might think actually that, like, you are too smart. So try to handle them correctly in that time, but be sure that you are not committing into a single algorithm. Just say, like, I go with all performance metrics and which perform very well. That would be my suggestion to go for that model. And also, at times, if it is a production, I also consider latency there. Okay, so usually random forest performs well, but it is one of a heavy, very heavy model, actually, like, so here itself, if you see, catboost was just, though it was the most outperformed model of among everything, it was having around 20 MB or 25 MB odd. Okay, I'm not very sure of that. But random forest, still I remember it. It was 240 MB. So how long it will take to run and then give me an output? Okay, it's going to be very long. So yeah, just like, think of everything and then answer for this specific question. Okay, that is a tricky question you all need to think of. Now coming to performance metric, because you need to know, right? So actually, whatever I've shown till now, it's whichever is light model. I'm just going to make a tick on that now. Okay, so logistic is light model, KNN is light model, SVC is kind of light but kind of like, hard. Like, I'll put like this. Okay, knife bias is light model. RF is a very heavy model. Gradient boosting kind of light and kind of a heavy. XGN boosting is very heavy. Cat boost is kind of a good, kind of a heavy. But like BGBM, it's one of the best model you can use. And then extra piece classifier, I don't even prefer that. I can, if I put
Yeah.
zero, that would be the best option.
Yeah, yeah. So these all models which Vasant is showing, can you switch that screen? Okay. So these all models, if you see from XGBoost, RF is random forest. For a short name, we say it as a random forest. The models which are seeing from XGB, These all are, you can say, state of the art model. Means you can say these all models have surpassed these all models, random forest and these all. But they are very heavy models. In cat boost, you do not need to even do some kind of a performing categorization and these all, like categorical encoding. It has already that all kind of a features. It will do automatically according to it. So these all models, XGBoost, CatBoost, light gradient boosting algorithm, these all are, you can say, are the state of the art models. These all models are used by many of the competitions. But at the end of the day, just start with the starting. Logistic regression, then KNN, then these are like random forest decision tree, and then at the end, if you are not getting result, then move to this model. If you are not getting even result from these all models, then we prefer creating a stacking. Vasan will tell you what is stacking, but
Yeah.
like averaging the prediction of different models and getting a result at the end.
Okay, so actually, yeah, he was talking about backing. I think he put it the wrong way, I guess, maybe. But yeah, that's what even I was trying to say. Even if all of these model fails, just go for custom assembling where, like, you'll have a data here. Just split your data with different model, and then, like, take all the models, okay, and take a average prediction of it, and you'll get a good model out of this. Okay, this is called as a custom ensembling model. Actually, we can see, like, usually the winning models usually at times will be custom ensembling model because they'll try to use different model. See, like, there is some good quality of each model. Like, for example, SVC performs very well with like, features, like, it will be able to make a hyperplane between them when there is a close relation. For example, apple like orange and orange like apple, it will be able to classify it very awesome. That is a good thing about SVC. Likewise, it will be able to classify text a good. So what will be an option if we can combine both of these? That can be done by using custom ensembling. So in that, one method is stacking. Okay, so what is RF? Random forest. Yeah, I think he said it actually. That's why I think he mentioned it. So yeah, now for the performance metric. Again, it depends based on what type of model you are choosing. Is it a regression or a classification or a clustering or else associative learning, whatever it is. So I'm just going to talk about regression and classification now, and I'm not going to explain like, everything in a very detailed way. So for us now, our focus is just regression classification, right? So in regression, we have mean squared error, mean absolute error, root mean squared error. These are the main three important performance metric you need to consider. And Ritesh, if you want to add anything, you can just add that also. Okay. So in classification, we
Yes, yes,
have
yeah.
accuracy.
Yeah, you can
Yeah,
add one more metric like MAP, mean absolute percentage error.
MAP.
MAP. It is also good like metric. But every you can get each and every task using these three metrics. The above top one metrics like MSC, MAE, and RMSE. Like these are the most important one. This is
Yeah,
just a, you can say, if you are building a research paper or doing some kind of a research, you can use MAP for that. Yeah, R2 score. R2 score can be added to the
yeah.
classification, I
R2.
guess. Yeah.
No, no. R2 is on regression.
Okay, okay.
I
Sorry,
thought,
sorry,
like,
sorry. Sorry.
yeah,
Yeah, sorry.
I thought, yeah. I thought, let me add R2 into deep learning models, but
Yeah,
yeah, I think.
adjacent art stores is also there. Adjacent art tool you can also add adjacent
But
art tools
usually
for.
for machine learning, we prefer these three actually.
Yeah.
But usually when we go for deep learning, the first choice would be R2 for deep
Yeah.
learning.
So it depends
Okay.
from like stack to stack. Like in deep learning, in NLP, we also do classification. So there we are having accuracy and score, value score, different kind of scores are there. So R2 score is
For
also one of the
integrals.
metric. It is a good one. Uh,
Yeah.
yeah, for like for in regression we can have R2, then adjusted R2 and so on. Like there are a lot of metrics. You go and search in the skill and documentation. You will find a lot of metrics which are present in the problem. Yeah, F1 score. Yeah, these all are the most important one. Like you can say at the end we are generating classification report. Classification report like at the end macro, micro, and I guess like AOC or RUC.
I that one. That's what.
AOC is, yeah, ROC and AUC score.
That's what. I
Yeah.
think they should be fine. this is the most commonly used metric. Adjusted R2. Yeah, yeah. It will be actually usually R2 and adjusted R2 is used in deep learning actually. We don't usually prefer it during machine learning. We usually use it in deep learning, but if you need, you're always welcome. Just use R2. That's all. The one thing which is R2, the good thing about R2 is actually that is the only thing will be acting as a kind of accuracy and not as loss. So whatever you have seen till now, your MAE, MSE, RMSE, okay, all of them are loss. We will be trying to reduce it. R2 is the only thing we'll be trying to increase it. Okay. So accuracy, yeah, accuracy. How accurate your model? That's all. Simple. How much good prediction it has made. That is accuracy. Okay, don't worry. I'm just going to explain each performance metric now, and when we need to consider what, I'll say that also. MSE, it is called as mean squared error. It will be like y minus y hat the whole square. Okay, that's all. MAE will be modulus of y minus y hat. Here, as it is when it is MAC, it will be highly penalizing. Penalizes high. Okay, this will be robust to outlier. So that's why we consider all of these. Okay, so we are also having RMSE, which will be root mean square error. Whatever we got there, root of y minus y hat the whole square. Okay, we'll be making a root of that. Okay, nothing more than that and all. So once it is done, MAPE is consider this MAE will be converting into percentage. How much percentage of mean absolute error is there? Okay, R2 is the distance between the correct one and the predicted value. Okay, so these are all the performance metric, and usually when you go, if you are also considering R2 as first choice, go with these four: MSC, MAE, RMSE, and R2. So first preference should be on R2 if you are considering R2. R2 should be first preference, then RMSE, then MAE. Okay, this would be my top three choices if you are considering R2. So if you are considering not R2, you are considering MAE, say not MSC, it will be at choice. Okay, so this would be for regression. Based on this only, you should need to choose. So here, if you see, R2 should be high, MSC, RMSC, MAE should be low as much as possible, low as possible, high as possible. Okay, could you please increase the brightness of pen? What brightness? Actually, I think I zoomed out a lot. That's the problem actually. If I zoom in again, it will be good actually. So for regression, just now as I said, first three choices would be R2 or MSC. So if you are considering R2 for machine learning models, so yes, they do. So first choice will be R2. Okay. Then MAE or else RMSC, and then the third one would be the other of those. Okay, so usually take this for second and third MAE. Okay, so this would be your choice where R2 high, MAE and RMSE low. Okay, so this is for regression. These are some common metric, but yeah, there are some other metric as Ritesh was addressing about. There are some other metrics, but these are the things we need to know about mainly, and these are the things where you need to choose on, based on these only you need to choose. So next we are having classification. First choice, if the data is imbalanced, no, you need not consider accuracy. Accuracy not at all to be considered there. Okay, so if it is not imbalanced, first choice should be accuracy. uh, okay, not imbalanced. Or else, if you have handled the imbalance, that's also fine. But usually, just go don't go with accuracy alone. Then, either of precision or recall, based on your problem statement. What do you feel is important for you? False positive or false negative? Based on that, you need to choose either of precision or recall. Okay. Next would be F1 score, and then last but not the least, but the most important, ROC AUC score along with its curve. Okay, this would be very important.
Okay, so like I guess confusion metrics can also give a good insight here. Like yes,
Yeah, I left it. Sorry, just now
confusion
I forgot
metrics.
it. Actually, when I say precision recall, I think that will also come. But yeah, I think
Yeah,
I
yeah,
missed it actually. I think
yeah.
I
Just
should put along with accuracy confusion metrics because confusion metrics is one of the most important. But yeah, when I was talking about it, I forgot it. Sorry for forgetting. And yeah, thanks Ritesh for just remembering me. I just forgot the most important metric we used to use for classification would be confusion metrics. And based on the confusion metrics only, guys, we are calculating precision recall and F1 score. Okay. Precision recall would be true positive by precision. Okay. True positive by true positive plus false positive. Recall would be true negative by uh, true positive plus false negative. Okay, so this would be a recall, and for F1 score, I'm not very sure on that. Just a minute. Anyway, I'll check it once. F1 score formula. I'll just check it once. Yeah, precision into recall by precision plus recall. 2 into precision by 2. And also, I'll show you for recall and precision also once. Recall score formula. Here it is. This is what we need. This image. Okay. So anyway, I'll put this true positive by true positive plus false negative equal to correct. Correct. See, that's what I've written here, right? So see here, like it is given clearly actually. This image, it's very clear. Okay. So I'll also ping the link of this image. Copy image address. I'm putting it in the chat. So if you need, just have a look onto that image also. Okay. So here it is very clearly given. Recall is this. Okay. And then for F1 score it is like this, and for accuracy it would be true positive plus true negative by true positive plus true negative plus false positive plus false negative, which means how much correct predictions by how much total predictions. That's all. Okay, so this would be the accuracy metric, and based on your problem statement only, we need to change it. Okay, yeah, I've made it as true negative. Sorry, my mistake. No, it's fine. So I'll also anyway write here accuracy would be true positive plus true negative by true positive plus true negative plus false positive plus false negative, and then we are having F1 score, which would be 2 times precision into recall by precision precision plus recall. I hope I done it correctly. Maybe I'll check it once. Yeah, 2 into precision by 2 into precision into recall by precision plus recall. Awesome. So these are all some metrics, and also we'll be finally considering ROC score and ROC curve. Curve must be as smooth as possible. Curve as smooth as possible. Score as high as possible. Okay, so now I think you all know a clear idea on the different performance metric we need to think of when we are having different problem statement. And based on these metrics only, you need to choose your model. Straight away, you should not go into a decision that I'm going to use this or that. Okay, so I'll show you how I've implemented for our project actually. Okay, here is a train prediction. Here it is. Until then, guys, if you have any doubts, hereafter, will you be able to choose your model on your own? What do you think of that? Just say, if you have any doubts, you're having Ritesh also here. He'll also help you. See here, I have literally implemented as much as models possible, starting with cat boost. Okay, I'll be showing you why. Actually, my favorite is cat boost. Okay, that's why. So it is giving me an AAC score of 0.89, ROC score of 0.755, and the curve is also very smooth. So random forest 0.88, the curve is very smooth. But the good part is logistic regression performed very well, 0.85. The curve looks good actually. And here if you see, naive bias didn't perform very well. It is having some kind of glitch here, right? 0.82, no, not very well. K bus K classifier, very worst. Okay, XGB also performed well. Okay, 0.88, and SVC performed well, 0.85. But the curve is smooth. That is very important. Okay, based on this, I came to a conclusion that I'm going to use cat boost. Okay, so because I can straight away say that I'm going to use cat boost. And if I do that, then there is no other worst person than me who can choose a model. If you're choosing a model, you should think everything like precision, recall, F1 score, your confusion matrix, your accuracy based on that, and if needed, at times macro average, micro average also at times will play a role. Weighted average, okay. But main things are these to consider at first. So yeah, actually, as I said, today it will be a detailed session, and yeah, it has been a detailed session. So it's time for questions. So you can put your questions. And Ritesh, do you think I have missed any metric, and do you want to add any metric? If you have
No, no. I
any,
guess like you have covered most of the metrics. Like you have covered most of the metrics. Like if you take 2 to 3 important metrics, your task will be done. Like problem statement to problem statement. Can't say like which metric we can choose, but in every competition or any question or problem statement you are solving, there is a particular metric.
yeah, in probably metric. But as I said, it depends on your problem statement. Okay, we'll try them today, and we'll. Ah, sure. You can shoot your questions, and yeah, we are going to finish our live now. Okay. So hope you will be present tomorrow because tomorrow will be the certificate link will be provided. Okay, and guys, if you haven't liked the video, just hit the like. If you like whatever I'm doing now, share it max and subscribe to the channel. Okay. So thank you all. Bye bye.